spend a day of your life just to get rid of a type mismatch that you don't even know from where it came from, you are not alone. You see, TypeScript can help us move way faster and find potential errors earlier, but sometimes it can be a bottleneck, especially when the two universes of JavaScript and TypeScript are colliding. We have a chaos. The editor is full of errors, and it's so difficult to write a single line of code. You catch yourself writing code only to satisfy the typing system. In this episode of Too Long to Read TypeScript, we will address exactly that. I will show you how you can use generics to make your types a bit more flexible and to use them under different circumstances. We will learn how they can be combined with plain functions, classes, and of course, interfaces. We will then use them to apply constraints for certain variables that are mysteriously unknown. It's a really powerful feature, and I know you will like it. So welcome back. Hello friends, it's Nikos here, and what if I tell you that there is a way to program your types? Do I have your attention? I'm glad I do. First off, let's see what is the problem and why we need generics. Let me give you a simplified example which demonstrates the challenge that we are facing here. Consider the following function. It echoes a title. Obviously, it accepts the title, which is a string, and it also returns a string. And all I want to do here is just return the title. Now let's call this function and pass a title. I wonder what this should be. I have an idea. Now if I try to call this function with, let's say, a number, I will get back an error because this function currently only accepts string, right? Which means that if I really want to have a similar function that works with numbers, all I can do is duplicate this function and have something like echo year, for example. And now we will change the title with the year, which obviously is a number. And now we can say echo year, which will work perfectly fine. But what if I have a function that works with both strings and numbers? Let's say, for example, that I have a function echo, which accepts something like an argument, and it just returns it for whatever reason. How can we add type annotations to this function? Well, somebody will just think, just use any. And yeah, pretty much this works. I can now have echo, and I can have a string, for example, hello, and I can also have a number. Hooray! Problem solved. Commit and push. Okay, so this video is over. We don't need to do anything else. Hello? Yes, I'm doing a video. Why? Oh man. Oh, I see. Okay, talk to you later. Ciao. Yeah, apparently we cannot use any. And the issue is that any disables type annotations. It may seem that it solves the problem, but it actually creates more problems. Something we can easily do is go here and say that this accepts string or a number, and it can also return a string or a number. So basically, we are using a union here, right? And although this may seem a good idea, but I don't think it's very convenient, right? Because what if this echo function receives a different types of objects, for example? And what if I only know as a consumer of this function what kinds of objects I want to pass? And what if the creator of this function doesn't have any idea and they don't even want to guess what kind of objects they want to support? So that's the challenge we are facing, And by solving this challenge, our journey in TypeScript will become much easier. If you think about it, a lot of functionality in JavaScript and TypeScript, of course, work in a similar way, right? There are plenty of methods that this can be applied very easily. For example, our array methods like map or reduce, or our most favorite console log. How on earth we can guard those things with type annotations? Well, my friends, all these problems can be easily resolved by using generics. And let me show you how they work. So I'm here in the example that we had before, and if you remember, we had this echo function, and we want this echo function to work with multiple types, but we cannot really specify the type here, and it's not a good idea to use any. So what if, for example, I had my type, which is a variable that stores the type, and I can then use this variable here in my return value. This is exactly how generics work. So all you need to do is, after the name of the function, specify the name of this variable. And we use this special syntax here, and inside here we can specify the name of this variable. So here I can say that this is my type. And pretty much that was it. So now our function echo is not just a function that doesn't have any type. It allows the consumers to specify the type, and the syntax is the same. So after the name of the function, when you call this function, you can specify the type that you expect this function to receive and return. And obviously here I will use a string, and here I will use a number. And this pretty much solves the problem that we had before. So now we pass the responsibility of us adding this type annotation to the consumers of our function, and we don't really care what they will send to us. This can be a string, this can be whatever, but they need to specify the type that they want. Otherwise, they will not have any type annotation whatsoever. So obviously, to test if this works, I can go here and say that if I expect, for example, a number and I pass a string, obviously this will fail. So what TypeScript is trying to tell us here is that, wait a minute, this echo function is expecting a number and you are trying to pass a string. This is not right. This is incorrect. And this is exactly how we can guard functions like this one, which they can work with any kind of type as long as their consumers specify the type. And remember, we are not limited to use the built-in types only. We can use our own classes, interfaces, types, or anything else. As you probably know, naming variables is a very difficult hobby. That's why, for simplicity, the TypeScript community has a naming convention. Instead of just coming up with a name here, they just use a capital T. And this will make your function much easier to read, because the reader can focus on the name of the variables and not the name of the types, right? So far we were explicitly setting the types here, but TypeScript can do type inference. So if I have, for example, a variable year, which is a number, and let's assign a year to it, and then if I say echo year, then take a look at this. If I hover over echo, so now TypeScript has implicitly inferred that the type of the echo, the type that echo expects, in this case, is a number. Now that you know how generics work, you can pretty much read any TypeScript code, right? And understand how they can use their types. Of course, this implies that you watched all the other episodes that you can find somewhere on screen. And make sure you subscribe, because there is more to come in the following weeks. So far, we've seen how generics can be used with functions. Let's review another example, this time with classes. In this series, we are making a music player, and what is the most important class for a music player other than playlist. Our playlist will have a collection of tracks, so this will be an empty array for now, and we will have a function to add tracks, so add to playlist. Let's console log this for now. And we will also have a method to remove tracks. That's a pretty dummy playlist, but for now it's okay. Let's add some types. So in order to add the types here, I have to add the type for my tracks list. And if you remember from the previous episodes, we used to have this class track. And basically our class has title, artist, released date, and this is favorite boolean flag. So one thing we can do here is we can specify that this is a playlist of tracks, and this will work just fine. So I can go here and specify that this is a track and this is also a track. So this will work perfectly fine. I can go here and create a track. And then add this track to my playlist. So I can have a playlist and then use the add method to add my track. So here's the thing. This playlist works pretty fine, but all it does is storing a specific kind of object. It's a track object. What if I want to have this playlist as a general class in my application, which will accept, for example, video, it will accept podcast, it will accept pretty much everything that a playlist can host, right? So we can use generics to add this functionality to our playlist. And let me show you how we can do that. So right after the name of the class, we can specify the name of our generic. I will call it T, and we can use it to replace our tracks. So this will be T. So now everyone who consumes this class, they should specify the type that they want. And I can go here and specify that this is a playlist of tracks, and my previous example will work just fine. But take a look at this. So if I come here and create a class video clip, which for now will have a name, then what I can do is use that class instead of track to create a new playlist. So I can now have a new playlist, video playlist, which will be a new playlist of video clips. This should not be here. Okay, now in my video playlist object, I can add a new video clip, and without even doing anything, TypeScript knows already the structure of this object. It's just a video clip. So I should create a new video clip and store it here. Of course, now I don't have the constructor, so let's add a constructor to our class quickly. And add a name here. And let me move these lines here and change the name of my previous playlist to a song playlist. So let's review what we have here. We have a class playlist that is a generic class. It can accept anything that we want, and this anything will be stored in a tracks array, and then it expects this anything when you want to add or remove tracks from this playlist. And then we have two playlists, one for songs and one for videos, and one is using the type track, which we know already it has a completely different structure than the other object, video clip, and this works perfectly fine. We have a generic playlist that we are reusing with different types, and both these playlists are protected with types. So if I want to do something stupid, let's say that in my video playlist, if I want to add a track, what TypeScript is trying to tell us now is that you have a playlist of video clips. You cannot add a track, right? And that's, my friends, how we can use generics in classes. Now let's review one of the most essential types. I'm talking about arrays. From the very first video of this series, we talked about arrays and I showed you the syntax. Let's create an array. So we have an array track titles, which is an array of strings. And let's add some values to it. Of course, here, if I try to do something stupid, like let's say add the number here, TypeScript will not allow because this is an array of strings, right? But there is another way to define arrays in TypeScript. We can use the built-in array interface. So let me show you how this works. We can have, again, let me comment out this one. We can have, again, track titles, which is an array of strings. And we can basically assign the same array into it. So as you can see here, if I command or control click on a Mac, you will see that Visual Studio Code will open the definition of this interface array. And as you can see here, I can perfectly read now that this is an interface array which accepts this type, and then I can read the full implementation of this array. So this is one of the core library files of the TypeScript language, and it uses generics to define all the features that normal JavaScript array support. And after this small parenthesis, let's go back to our playlist class and let's implement the functionality we left behind. So if you remember, we have add to playlist and remove from playlist, which I would like to actually implement. And I don't like this tracks name here. This must not be tracks, it must be something generic. So I would use items for my list here, and add to playlist will accept a new item. And now what I would like to do is remove this console log statement here and implement this function. So this basically will push the new item. Awesome. So let's repeat the same thing for my remove from playlist method. In this one, I don't really need the track to be passed here as an argument. What I really want is the ID of the track, of the item. And I want somehow a convention that all these items should have a unique identifier. So this will be the ID to remove, and this will be, let's say, a string. And here, for example, instead of having this console log statement, we can add the functionality that removes this item from the list. So to do that, I will use a filter, and my filter will basically get an item, and it will try to check if the item ID is not equal with the ID to remove. And this will work perfectly fine. So let's move this to another line. And we have an error here. How unfortunate. It says that basically because the type T is unknown, we are not sure if it has the property ID in it. So we need a way to instruct TypeScript that all these types we are expecting as a parameter here, they should have the ID property. So we are expecting probably objects that contain an ID property, and this ID property should be a string. Well, I know what we need here. We need an interface, and if you're not familiar with interfaces, I have another video, you should check it somewhere here. And yeah, let's implement this interface. So basically my interface will have a name, let's call it with ID, and it expects from the objects or the classes who will implement it to have an ID which will be a string. So this will work perfectly fine. But how can I associate that playlist, this type generic here, will need to implement this interface? To do that, I can use the keyword extends. So I can go here and say extends with ID. And by doing that, the error that we had before will not be an issue anymore, because here we are saying that whenever you create an object using this playlist class, we are expecting a type, and this type should extend this with ID interface, which means basically that it should be an object with this ID, which must be a string. And this, of course, will solve the problem. Now, if I scroll all the way down where I use this playlist class to instantiate my playlists, I will see that both track and video clip don't have IDs because their classes don't specify any IDs. So let's go and fix this issue. I will start with the track class, and here we can say that this track implements with ID, and we can add an ID which is a string, and in order to make it work we need to add it in our constructor. Excellent. So now I need to go all the way down and refactor this track here. You will see that we are expecting the ID to be the first parameter, so let's add an ID here. We have also the video clip class, and what I can do is add the ID here, which will be a string, and add it in the constructor. So this will be new ID. And let's specify an ID for my object here. Perfect. And this solves the problem. One last trick that I want to show you is that you don't really need to use an interface here. You can avoid the interface if you simply pass the object here and say that you are expecting an ID which will be a string. This will work in the same way, but it's really better to use an interface here because as you keep adding parameters here, you are basically making your class harder to read. And I personally like using interfaces because you can also reuse this interface somewhere else in your code, and as we saw, we use this interface in our classes. Another note I would like to mention is if you noticed, we didn't implement the interface in our video clip class, right? We forgot to put implements with ID, but this doesn't mean that it's not working, because TypeScript is not complaining at all. And that's because of the structural type system that we mentioned in the previous episodes. TypeScript will basically compare these two objects and will check if we are expecting this ID here. Do we have this ID, which is a string, in our object structure? Whatever this object could be, right? If yes, then we will definitely accept this without any issues. So this is what TypeScript is doing, and that's why we don't need implements explicitly to be defined here. So far, we've seen how to use generics with plain functions and classes. Now, let's see how it works together with interfaces. In our previous example, we used the interface with ID to guard all our generic types with an ID which is a string. But what if we have other kind of types for IDs? For example, what if our track would like to use a string, but our video clip would like to use a number, for example. So as you can see here, since my video clip class expects a string, this is not working. But what if I go here and change this to a number? This will work fine, but then I have another problem. My playlist class is not compatible anymore with our video clip class, because playlist expects the ID to be a string, but my video clip expects it to be a number. So it will be really nice if I will be able to specify the type of the ID within my interface itself. Of course, I can use generics, and of course, we can use the same syntax that we used for our classes. So here, what I can have is a type, and I can use this type here. So now my interface expects a type, and what I can do is go back to my track class and add this type here. So this class track implements with ID, and the ID will be string. And now this works just fine. Of course, I can go back to my video clip class and do the same if I want to, but I will leave it just as it is because I believe it will work just fine. But what we really need to do is go to our playlist class and specify the type of our ID here. Now here's the catch, how you can find the type, because here we are still in our generic playlist class. I don't know the type of the ID, right? Because somebody will use it as a string, somebody would like to use a number. How can I allow them to basically specify what type they want? Well, you guessed it right, we can use a generic. So I can have another generic type, and this time I can have the ID type. But nobody passed me this ID type, and as you can see, this throws an error. So somehow we need to declare that we have this ID type, right? And yes, we can. So long story short, you can have as many generic types as you want. And what I can do is define another one, which I will call ID type, just to be sure that I remember what this type is about. Now I can go back to my playlists. And for the song playlist, what I need is a track, and the ID type should be a string. And for my video playlist, I need a video clip, and the ID should be a number. And this works perfectly fine. So let's recap what we've done, because it's a little bit complicated, right? Here I'm using this playlist, and I pass two kinds of types. One is the track and the other one is the string. And here in my playlist class, I'm reading these values here because I have, let's say, two parameters, two generic types, which I name T and ID type. And then I can use these two types anywhere I want. So obviously this ID to remove here will be an ID type and not a string. And this will solve all the problems. And this, my friends, is the power of generics. It's a way to define reusable code that works with multiple types. This can be functions, interfaces, or classes, as we've seen. It reduces code duplication and unnecessary code that you write just to satisfy the type system. And of course, it limits the usage of any in your code. I really love this feature, and I can talk endlessly about generics. They have so many applications. I promise I will make a follow-up video. I have some very nice utilities that I would like to show you. There are building utilities for generics in TypeScript, but you can also build your own if you want. So make sure you subscribe because you don't want to miss this episode. And as always, you can read everything I just told you in my blog post about generics, which also contains all the coding examples. It's a very nice way to review what we've learned today. If you like this video, then press the thumbs up button. If you didn't like it, then press the thumbs up button. Thank you very much for watching this video and for supporting my channel. See you in the next one, and have a very nice creative day.